This is the GCSE Biology Required Practical Activity, photosynthesis. Here we have the apparatus that we will require to help us with this investigation. And starting at the back, we have a boiling tube and a test tube rack. There is an empty beaker, I'll show you what that for is later. Sodium hydrogen carbonate solution. There is freshly gathered pondweed, a timer, stop clock, and a light source and a ruler. Right, I'm sure you're aware that plants use carbon dioxide in order to carry out photosynthesis to produce glucose and oxygen. And in the photosynthesis reaction, the oxygen, as it's released, it can be detected, particularly if the plant we use is an aquatic plant. So we use the waterweed, and the advantage of this is that any bubbles that are produced, we should be able to see them if we look closely at it in a beaker. Now, in this large container, I've got quite a lot of pondweed. I'm looking for a piece that's about 10 centimeters long. That one's not quite it. Okay. Now, if I can find one that is suitable, I can just cut it off with a pair of scissors, and then I will have the subject for my experiment. I think this one here looks close to 10 centimeters. So I measure it. Oh, beautiful, 10 centimeters, and I don't need this spur on the edge. So I will pull that off and drop it back into the main beaker. Just to make sure it's freshly cut, I can snip the bottom end with my scissors. Right, now the easiest thing to do is then to put the pondweed into the boiling tube, and that's where the glass rod comes in. And I just use that just to push it down nicely to the bottom. And then I'll need to add the sodium hydrogen carbonate solution. The advantage that gives me the water, but there's also carbon dioxide dissolved in the water, and the plant can use that for photosynthesis. Right, here's the apparatus set up, almost ready to go. You can see we have the pondweed, about 10 centimeters length, and a boiling tube, and the boiling tube is filled with sodium hydrogen carbonate solution. We've got a light source next to it, that happens to be a desk lamp. Now we're almost ready to go, as I said. Obviously, the closer the lamp is to the tube, the greater the light intensity. And as we move it away, the amount of light falling on the pondweed will decrease. There's also a problem there. Because this lamp produces quite a lot of heat, we don't want the pondweed to warm up as we go through the experiment. So in order to prevent that, we'll use another beaker full of water to act as a heat shield. And I'm using a tripod, gauze on top, and the empty beaker we saw before. Now, like that, I guess that would work quite efficiently, but if it was full of water, it would be sure to absorb more of the heat energy that could get to our boiling tube and warm it up. Here we are about to begin. Now, just one point, just to make sure everything is settled in, I'll just push the pondweed into position with the glass rod, and now we're ready to begin. We need to work out how far the light is away from the pondweed, and I'm going from the edge of the rim of the light shade to the front of the boiling tube, and I make that to be 10 centimeters. As I mentioned before, the water in the beaker will act as a heat shield and stop the temperature of the pondweed rising. I'm pretty sure you know that temperature would affect the rate of the reaction. Now it's simply a matter of switching on the lamp, and we leave it for 5 minutes for the pondweed to acclimatise, and then we will start counting the number of bubbles. After leaving the apparatus to stabilise for 5 minutes, we can return, and now we're ready to count the number of bubbles being given off by the pondweed. Now, how many bubbles it gives off will obviously tell us the rate of reaction. The more bubbles, the faster the rate of reaction. We'll just need to count the number of bubbles in 1 minute. I'm not sure yet if you can clearly see the bubbles, but I'm ready to start, so here goes. This is the area we'll look to see any bubbles coming up, and we'll take that as being indicating how well the rate of reaction's going. The experiment is simply the matter of starting the stop clock, and whilst it's running for a minute you count the number of bubbles that are produced at this end of the pondweed. There are a couple of safety points to take into consideration. Obviously we have an electric light and it's in close proximity to water, as well as being the risk of electrocution. If we touch the bulb we may get burned. We've got glassware and all the usual hazards associated with breaking glassware. In this case, where the independent variable is the light intensity, we're increasing the distance between the light source and the pondweed. And as the distance increases, the intensity will decrease. So for the next experiment, it's simply a matter of moving the lamp back from 10 centimeters to 20 centimeters. And then we're ready to start counting the bubbles produced again. So it's start the stop clock, and we'll count the number of bubbles produced in a minute. After that minute, we'll increase the distance again between the pondweed and the light, and that will reduce the light intensity. Those numbers need to be stored in an appropriate table. Right. Once we've done the measurements with a distance of 10 centimeters between the pondweed and the light source, the next stage is to increase the distance in 10 centimeter increments. And then once we've done that, we'll be able to plot the number of bubbles against the distance. The number of bubbles, of course, give us an indication of the rate of reaction. Don't forget the usual safety problems where we have electricity and water in close proximity. We also have an opportunity to burn yourselves on a hot lamp, and there's a risk for the broken glassware.